All right, time for more fun. So what we have now is that we have some problems we're going to work through where I'm going to give you one of the trigonometric function values. I'm going to give you another hint about this. And from those two pieces of information, we're going to find the other 5 remaining trigonometric function values. So when we do this, it's all about drawing good pictures. Now, I know the textbook does something, but to me, they make things more difficult than it has to be. And I get that they're trying to get you to use the identities that they have there, but really, draw the picture. That's going to be the easiest way to do it. So from what we have here in the notes, number 7, if I tell you that the cosine of theta is equal to negative 4 over 5, and I tell you that the theta is in quadrant 2. Okay, so first of all, I'm in quadrant 2. Draw your picture. If I'm in quadrant 2, that means that I'm going to have a ray that's coming out here into quadrant 2. And I'm going to be dropping the perpendicular down to the x-axis. You just have to start with that. Okay. Now, looking at my picture, I know that my x value is going to be negative because I'm going to the left. My y value is positive, and of course my r is always going to be positive. Now remember when we did SOHCAHTOA. So cosine, so you know what? At the top of every page, you should probably write SOHCAHTOA. Do that, remember it. So we're dealing with cosine, and that means adjacent, so that is adjacent over h, which is the hypotenuse. So let's put that in our diagram. The hypotenuse is 5. The adjacent side to our theta, of course theta is always formed by the x-axis and the terminal side. Let's see, adjacent is negative 4. All I need to do is find the y value. But I feel like we have some kind of Pythagorean triple that has 5 for the hypotenuse and 4 for one of the legs. And if you remember, that's going to be 3. Now, if you forget, make sure that you correctly apply the Pythagorean theorem. So you could say this. So we have negative 4 squared plus the unknown y squared is equal to 5 squared. So take this equation and solve this. So y squared is equal to 9, which means y is going to equal 3. Okay, so do it the long way if you need to, but just do it and do it well. But now that we have this triangle established, it's like the problems we did in the last section. So my sine is supposed to be opposite over hypotenuse, which is 5. Even though I already have the cosine written, I'm going to write it again. My tangent, again, look at this. TOA, opposite, 3 over adjacent, which is negative 4, put the negative in front. All right, you've got the 3 main guys. Now flip this over and do the reciprocals. So the reciprocal of sine is cosecant. We're going to turn this guy over, and that's 5/3. The reciprocal of cosine is secant. Turn it over, negative 5 over 4. And the reciprocal of tangent is cotangent. Flip this over, negative 4/3. And you're done. Like that is all you have to do. Get the picture, label it correctly, do sine, cosine, tangent, and then do the reciprocal of each of those. Now, again, pay attention to the fact that we were in quadrant 2, so that helped us identify our signs. As we were talking about this in an earlier video, all students take calculus. So we're in quadrant 2, which means only sine and its reciprocal cosecant will be positive. And that's exactly what we see. Everything is lining up. All right, let's see. What does number 8 say? Number 8, ooh, gross. Tangent of theta is equal to the square root of 7 over 3. Theta is in quadrant 3. All right, draw my picture. I'm in quadrant 3. So my theta is right here. Draw my triangle. All right, so remember tangent, SOHCAHTOA, that's going to be opposite over adjacent. So in my diagram, the opposite side is the square root of 7. The adjacent side is 3. However, pay attention to the diagram. You're down in quadrant 3, which means your x value is negative. Your y value is also negative. And you might say, but my tangent value is positive. Well, remember, it's the quotient of the y and the x. So it's a negative over a negative, which makes it a positive. Now we just need to find the r. All right, so that's going to be, let's see, we have the square root of 7 squared, the square root of 3 squared, or plus 3 squared, excuse me. We end up with 7 plus 9, so we have the square root of 16. Oh, look at that. How nice is that? We just get a 4. Well, it must be my birthday. All right, so let's check out sine. Sine is supposed to be opposite over hypotenuse. Cool. Cosine is adjacent, negative 3, over hypotenuse, 4. Tangent was already given to us. Square root of 7 over 3. Again, they were both negatives. They reduce to give us the positive. Now let's do the reciprocals. Cosecant is going to be the reciprocal of this guy, so that's negative 4 over the square root of 7. And if I do square root of 7, square root of 7, we have negative 4 square roots of 7 over 7. So again, got to practice rationalizing these guys. The reciprocal of cosine is secant, so do the reciprocal, and that is, oh, that's nice, negative 4/3. Cool. Cotangent is the reciprocal of tangent, 3 over the square root of 7. Rationalize, we have 3 square roots of 7 over 7. All students take calculus. In quadrant 3, only tangent was going to be positive, and also cotangent. And we see here with our work that that's true. Only tangent and cotangent were going to be positive from this. All right. And let's look at the next one. Number 9 says that the cosecant of theta is 9 over 4. Theta is in quadrant 1. All right, so I'm over here somewhere. Drop that perpendicular. Here's my theta. Okay. So here's what I'm going to think for this one. I know that cosecant and sine are reciprocals of each other. So that means that right now, sine is supposed to be the reciprocal of that, which is 4 over 9. And I can use that with SOHCAHTOA to start labeling my diagram. So means opposite over hypotenuse. So the opposite is 4, the hypotenuse is 9, and I need to find the missing leg. All right, so 9 squared is equal to x squared plus 4 squared. And we're just going to solve this. Shouldn't take us too long. So subtract the 16 on both sides. Take the square root. We only need to worry about the positive square root. And we have the square root of 65. So that's going to be that length right there. Kind of gross, but what are you going to do? Cosine is adjacent over hypotenuse. Don't need to do anything extra with that. Tangent is opposite over adjacent, but I do have to rationalize this. So square root of 65 for both of these. So we have 4 square roots of 65 over 65. Now to do the reciprocals. So we already know that cosecant is 9 over 4. For the secant, we need to do the reciprocal of cosine. 9 over the square root. Sorry, this part is a little bit messy. Just trying to get through this. All right, so that's 9 square roots of 65 over 65. And then for cotangent, let's do the reciprocal of that piece right here. So the square root of 65 over 4. All right. So for this one, since they didn't give us like a sine, cosine, or tangent, for me, it's better if I go ahead and convert that to something I do know, like sine. And once I know the sine, I know that sine is, so sine is opposite over hypotenuse. Put that in the diagram, and I can find the missing side. So that's how I go about doing a problem like that. Number 10 says the sine of theta is negative 4/7, and my cosine is going to be positive. That doesn't necessarily tell me what quadrant it's in. Or does it? Let's see. Now, if you've been paying attention, you may remember that I said that sine is heavily connected to the y. So if sine is negative, that means it has to be in one of the 2 bottom quadrants, either in quadrant 3 or quadrant 4. And where is cosine positive? Cosine is positive in quadrants 1 and quadrants 4. So it seems to reason that that's the region where my theta lies. Because sine is negative because it's down and cosine is positive. So let's see if that works out. Okay, let's do the perpendicular like we've been doing. There's my theta. So sine is supposed to be opposite over hypotenuse. So 4 over 7, but it's going to be a negative 4 because you see that we're going down. Find the missing side length right here. So that means that 7 squared is equal to x squared plus 4 squared. You know, the more of these you do, the more that you can learn to manipulate the Pythagorean theorem to do your will. So we could easily say that x is going to be the square root. It's almost like you're doing the distance formula, but you start with the hypotenuse and you take away that known value. So 49 minus 16, and we get the square root of 33. So square root of 33, it's positive because we're going to the right. All right, we already know sine. Cosine is supposed to be adjacent, square root of 33 over hypotenuse, which is 7. Tangent is opposite over adjacent. Oh, man, I got to rationalize again. All right, so that's negative 4 square roots of 33 over 33. All right, now to get those reciprocal values. So cosecant is the reciprocal of sine, so it's negative 7 over 4. The reciprocal of cosine is secant, so 7 over the square root. More rationalizing. So that is not what I want. 7 square roots of 33 over 33. And finally, cotangent of theta is going to be the reciprocal. Let's start up here. So that's negative square root of 33 over 4. Now, one of the things I do want to mention here is that you notice I don't say cotangent equals. I don't say sine equals. It's sine of theta, cotangent of theta, cosine of theta. So if you don't have the theta or whatever the angle measure is, if you don't have that listed and you just have COT or SIN, that is not acceptable. You need to make sure that what you write is similar to what I write here using good function notation. All right, so again, draw the pictures, pay attention to your signs, no problems.